can make really cute stickers with your M1 Ultra. I mean, look at these little guys with their itty bitty protective laser glasses. There's two ways that you can do this with the M1 Ultra. The first way is admittedly a lot simpler. You can straight up just use their software to do a two-step process with the inkjet module and the blade cutter. All you do is you print first and then you do the cut. Nothing moves and you get accurate lines. But what if you want a little more control over the color management, the print quality, and the kinds of papers you can use? Then the second option is basically to use a separate printer. The issue is then how in the world do you line up everything perfectly so that you get an accurate cut around your stickers? Well, since the first method of using just XCS software is pretty simple, I'm going to go over how I like to do it hard mode style. But it's really not all that hard because all you need to do is learn how to use the precision marking system. Now, for those of you who are new to sticker making, I'm going to go over the materials that I'm using. I will leave links down in the description below for all of these products. First off, we have vinyl sticker paper that is specific for inkjet printers. The reason I go with matte paper is because I give it the glossy look afterward by applying laminate. There's two laminate products that I like to use. First is just this basic clear permanent adhesive vinyl. I like that it comes on a roll so that I can just cut out a little bit that I need. The second one is a lot more fun because it's holographic designs. So sparkly. The last thing that I strongly suggest that you get is a squeegee type tool. You'll use this thing to smooth out the vinyl that you place on top of the sticker sheet so you don't get any bubbles. You can, if you want, just do it with your fingers, but you'll probably hate yourself later. First, I need to create my sticker sheet with precision marking in mind. I prefer to use a vector graphics editor like Illustrator for this part. Most printers have an option to print with registration marks, but that won't work here. We need to create our own registration marks to print and export in an SVG, which is later referenced for the cut process. To create my own registration marks, I place a simple rectangle in the center of the artboard that acts as the boundary. It needs to be within the printer margins. I keep the stroke really thin, only 1/4 of a point, because it'll be easier to see if the laser's crosshairs are centered over them when they're thin like this. To create the cut lines, I use the pen tool to create a path just outside of my sticker's image. This is the more manual way of doing it. You could also use the image trace functionality to get the outline of your raster graphic and give the path an offset. It should also be noted that while you can do this in xTool software, it's best to be consistent with managing your artwork and use the same program to generate both the printable sheet as well as the vector cut file. Of course, I don't do this however many times I need for each sticker that's going to be on the sheet. I create just the one cut path, then duplicate everything throughout the document so I reduce the amount of work. I save two versions of this file. The first will be a high-quality PDF with just the sticker artwork and the rectangle. The second file will be an SVG file with just the cut lines and the rectangle. I print out the PDF on my inkjet printer, making sure that I don't apply any automatic scaling. It should be set to 100% and accurately reflect the artwork. After it's printed, I can then apply a layer of vinyl laminate film. I find it's easier to place the laminate sticky side up and then lay the sticker sheet on it, starting from one end and smoothing with my hands in a sweeping motion to gradually lay it all the way down. I use the soft side of the squeegee tool to apply pressure and smooth it out from the back side. Then I flip everything over and squeegee out any of the remaining bubbles from the front. This also makes for a more secure adhesion of the laminate. Now it's time for the cutting step. In XCS, I start a new project and set its mode to blade cut. I then import the SVG file that I created alongside the printable PDF. This typically comes in as a group, so I ungroup it and then select just the rectangle. I need to turn off the output flag for the rectangle so it doesn't get included in the cut process. I select all of the sticker outlines and set the pressure and speed. If I'm doing a die cut, meaning the sticker is fully cut out from the sheet, I'll use 450 pressure and then 15 for the speed. If it's a kiss cut, meaning the sticker isn't cut all the way through the backing paper, I'll lower the pressure to 150. Now that I have the file set up for cutting, I can take my laminated sticker sheet to the M1 Ultra. I start with the upper left corner of the rectangle. I use the crosshair to line up the top and left lines of the printed rectangle. Then I hold down that corner and smooth out the remainder of the sticker sheet to the cutting mat. Now you might be asking yourself, why is she doing this if she she has that corner lined up perfectly. Well, the thing is, dear viewer, I realized after some trial and error that sometimes prints will print out slightly stretched or askew depending on how well or unwell your printer loads paper. So even though that top left corner seems lined up just fine, the further away you get from that point, it's gonna go a little sideways. So let's get into showing you how to use that precision marking system so you can understand the best way to get those accurate cuts. Back in XCS, I go up to the little flag icon to access the precision marking system. Click on the flag icon and then select the Mark menu option. There are several options for the shape of the area you want to mark. I like to use polygon for this just so I can have a more accurate perspective of the layout. To set your points and build the polygon marking area, all you have to do is manually move the module to each point. Line up the crosshairs, then press the plus button on the front of the M1 Ultra. This is a separate button from the silver start button. I mark all 4 corners before going back to the software. The area will show up as a black outline. I can then select all elements of my design, including the rectangle, and adjust the location and angle so that my SVG's rectangle lines up with the marked area. You'll notice that my SVG is actually longer than the marked area. Remember how I said the printer can have some discrepancies? This is one of those odd little deviations you don't notice with the naked eye. It took me a bit to figure out what was going on. All you need to do to resolve this is select everything, turn off the locked aspect ratio, and adjust the height by pulling up from the bottom of the selection bounds until it's aligned with the marked area's bottom. Now you can send the design to the machine for cutting and get those beautifully accurate cuts without needing to build in a ton of safety space around your artwork. All 9 potato cats turned out great. Look at how consistent the cuts are between each of them. I expect to have a little deviation here or there. That's the whole point of having a bleed area for printed artwork, but this is pretty much perfect. And there you have it, a complete batch of accurately cut potato cats. The precision marking feature isn't limited to the M1 Ultra. It's part of the XCS software, so you can use it with all xTool products. It's just especially useful for the stickers. So I hope that helped you out. Feel free to like the video, subscribe to the channel for more information on not just the M1 Ultra, but other laser, sewing, or machine embroidery shenanigans. Not to mention, every subscription gives me an added excuse to purchase more stuff.